Good morning. This is Hassan Nageh, Assistant Professor at the Nanotechnology Research Center at the British University in Egypt. Thanks a lot to Professor Medhat Ibrahim for this chance to present some of our work. I would present the fabrication of nanofibrous zinc oxide loaded on polyvinylidene fluoride in protection from adenovirus. I would present some of our experimental results as well as some of our simulation results. Here is the table of contents of our work, starting from introduction, loading of zinc oxide on polymer, and characterization and the antiviral activity of our materials against adenovirus, ended by molecular docking calculations and conclusions. Viruses are one of the big crises threatening the world, and it classified into DNA viruses and RNA viruses. And you can see here adenovirus in its proposed structure with almost Hexon protein on its surface. For example, the infection diseases happened on last centuries via Black Death and influenza caused around 50 million deaths and around 0.5 billion infection. So there are a big need to disclose different types of antiviral materials to stop the spread of these pandemics. By looking to the available materials around us, there are a wide variety of metal and metal oxides that possess antibacterial and antimicrobial activities. In addition to the presence of new techniques that could fabricate nanofibers. On this work, we aimed to load the metal oxide on polymer and ensure its full characterization, then apply it as antiviral agent against adenovirus. After successful loading of zinc oxide on polyvinylidene fluoride and successful electrospin of those materials, we have investigated its morphology, which appeared by SEM to have the nanofiber structure. And we noticed that this increasing the zinc oxide content led to increase the bead ratio in the nanofiber structure. Also, the EDX analysis indicated the content of zinc oxide on the nanofiber. To ensure that the zinc oxide chemical composition not affected by the electrospinning process, we studied the XRD of zinc oxide and zinc oxide loaded on PVDF polymer. And we ensured that the phase is still the same and no change on the peaks, as well as no any impurities appear. Also, we conducted FTIR analysis to ensure the chemical composition of the prepared material not affected after the spinning. There was obvious enhancement in the mechanical properties of the prepared nanofiber with increasing the zinc oxide content. And the prepared nanofiber was stable up to 5 months in ordinary shelf. Before going to the antiviral test, we have studied the cytotoxicity of our prepared materials, and all materials we have prepared appeared to be safe against virus cells. In our antiviral activity test against adenovirus type 5, we have applied it into different mechanisms: adsorption mechanism and virucidal mechanism. And we have noticed that in case of zinc oxide loading in 5%, it worked on both mechanisms, while in case of 2% of zinc oxide, it not worked in the case of adsorption mechanism, but only worked in case of virucidal mechanism. To ensure our data, we have applied the molecular docking calculations on Hexon protein, which is the most dominant protein on the adenovirus surface. We have studied the interaction of zinc oxide and its polymer on the Hexon protein. And finally, the conclusions that we got: we have successfully fabricated the zinc oxide loaded on polyvinylidene fluoride via electrospinning technique, which can be applied in large-scale fabrication. We determined the safe dose of our used material. We elucidated that the antiviral activities of our material against adenovirus in both mechanisms, adsorption and virucidal mechanisms. We studied the affinity of our material against Hexon protein using molecular docking calculations. This work was done at the British University in Egypt, which is located in Cairo city, especially at the Nanotechnology Research Center. This was a part of a project between Nanotechnology Research Center and the Nageh company. And here is the teamwork of this project. This project was initiated by Professor Amal Qasri, and I have served as PI since last May, and it funded by the Academy of Scientific Research and Technology. Finally, thanks a lot for your kind attention.